Welcome to Astronomy Daily, your source for the latest space and astronomy news. I'm Anna.
And I'm Avery. Thanks for joining us on this Saturday, January 24th, 2026. We've got some fantastic stories lined up for you today.
We certainly do. From rocket development milestones to prehistoric lunar discoveries, today's episode is packed with celestial intrigue.
Let's dive right in with our top story. Rocket Lab's ambitious Neutron rocket has hit a significant milestone, even though it came with a bit of a bump in the road. Anna, what's the latest from Wallops Island?
Well, Avery, it's a story of both triumph and setback. The good news first. Rocket Lab's innovative Hungry Hippo fairings have successfully arrived at Wallops Island, Virginia, after a month-long sea journey from New Zealand aboard the vessel North Star Integrity. These aren't your typical payload fairings. They're part of Neutron's groundbreaking reusable system.
Right, and what makes these Hungry Hippos so special?
Great question. Unlike traditional fairings that are jettisoned and lost during flight, these clamshell-like structures actually stay attached to the first stage as it returns home. They open to release the second stage and payload, then close back up for the ride home. It's a clever design that should help drive down launch costs through rapid reuse.
That's fascinating engineering. But you mentioned a setback.
Unfortunately, yes. While the fairings were making their journey, Rocket Lab experienced a tank rupture during qualification trials at their Middle River, Maryland facility. A first-stage carbon composite tank failed during hydrostatic pressure testing. That's where they fill the structure with water and gradually increase pressure to verify it can handle operational loads.
Ouch. How significant is that?
Well, Rocket Lab was quick to emphasize that testing failures like this, while disappointing, are actually part of the rigorous development process for high-performance rockets. They deliberately stress hardware to its limits and beyond to ensure reliability. The tank was found collapsed into a pile of debris, but the company maintains this is exactly why they test, to find these issues on the ground rather than during flight.
Silver lining thinking, and the program moves forward.
Absolutely. With the Hungry Hippo fairings now at Wallops, engineers can proceed with integration testing, fit checks, electrical interfaces, and eventually static fire preparations. The launch mount is already in place with the test stand, ready for major testing with the rocket's second stage.
Exciting times for commercial spaceflight. Now, speaking of major missions, NASA has some news about tracking the upcoming Artemis II mission, right?
They do indeed. NASA has selected 34 global volunteers from 14 different countries to track the Orion spacecraft during its journey around the moon. This is a significant expansion from the Artemis I mission, which had only 10 volunteers.
So what exactly will these volunteers be doing?
They'll be using their own equipment, everything from established commercial service providers to university research facilities to individual amateur radio enthusiasts to passively track radio waves transmitted by Orion during its approximately 10-day mission. We're talking about 47 ground assets spanning the globe.
That's impressive international cooperation. Who made the cut?
The list is quite diverse. Government agencies like the Canadian Space Agency and Germany's DLR are participating. Commercial companies include Goonhilly Earth Station in the UK, Kongsberg Satellite Services in Norway, and Intuitive Machines in Houston. Universities like UC Berkeley, the University of Pittsburgh, and even Morehead State University in Kentucky are involved.
What about amateur radio operators?
Oh yes, they're well represented. We've got individuals like Chris Swire from South Dakota and Dan Slater from California. Amateur radio organizations from Argentina, Germany, the Netherlands, and France are also participating. It's truly a global effort.
And this data they collect, what's NASA doing with it?
The volunteers will submit their tracking data to NASA for analysis. This helps the agency assess the broader aerospace community's tracking capabilities. and identify ways to augment future Moon and Mars mission support. Kevin Coggins, NASA's Deputy Associate Administrator for Space Communications and Navigation, called it a real step toward SCAN's commercial first vision.
Building that public-private ecosystem for deep space exploration.
Exactly. Now, let's shift gears to some groundbreaking lunar research. Scientists analyzing samples from China's Chang'e 6 mission have made a discovery that helps explain one of the moon's most puzzling features.
The asymmetry between the near and far sides?
Precisely. You know how the near side of the moon has all those dark maria, those vast volcanic plains that formed the man in the moon pattern we're all familiar with? The far side has barely any.
I've always found that fascinating. What did they discover?
Chang'e 6 brought back samples from the South Pole Aitken Basin, which is one of the largest impact features in the entire solar system, about 1,600 miles wide and between 4.2 and 4.3 billion years old. Much older than the lunar maria, which are around 3.6 billion years old.
And what did these ancient samples reveal?
The research team, led by Hengxi Tian from the Chinese Academy of Sciences, found something unusual in the basaltic rock samples, an abnormal ratio of potassium isotopes. Specifically, they found more of the heavier potassium-41 relative to potassium-39 compared to samples from the near side.
What would cause that?
After exploring several possibilities, cosmic ray irradiation, magma processes, meteoritic contamination, they concluded that this isotopic signature is a relic of the giant impact that formed the South Pole Aitken Basin itself.
So the impact actually changed the moon's chemistry?
Not just changed it, it fundamentally altered it. The impact was so violent that it heated the moon's crust and mantle intensely, causing many volatile elements, including potassium, to evaporate and escape into space. The lighter potassium-39 isotope evaporated more easily than the heavier one, leaving behind this unusual ratio.
That's incredible detective work. And this explains the lack of maria on the far side.
Exactly. The reduction in volatiles would have suppressed magma formation, limiting volcanism on the far side. It shows how deeply that ancient impact affected the moon's interior, and why isotopic analysis can provide windows into the conditions of such catastrophic events. This research was published in the Proceedings of the National Academy of Sciences.
Fascinating stuff. Now here's something a bit more down to earth, even if it's going to space. Anna, tell us about this startup that's making space memorials affordable.
This is a really interesting story, Avery. A startup called Space Beyond, founded by Ryan Mitchell, is planning to send up to 1,000 people's ashes to space in October 2027 for as little as $249, dramatically cheaper than traditional space memorial services that typically cost thousands of dollars.
That's quite a price difference. How are they pulling this off?
It's all about smart use of existing infrastructure. They're using a CubeSat, one of those miniature cube-shaped satellites that will launch as a rideshare payload on a SpaceX Falcon 9 rocket. The rideshare model has really democratized access to space.
And Ryan Mitchell, he's got some serious space credentials, right?
Absolutely. He worked on NASA's Space Shuttle program and spent nearly a decade at Blue Origin. The idea actually came to him while attending a family member's ash-spreading ceremony. He thought, how could I do this better? And thus, Space Beyond was born.
But there must be some limitations with such an affordable service.
There are. Customers can only send about 1 gram of ashes, a practical limit due to weight considerations and the need to fit many customers' remains in the CubeSat. The satellite will only orbit for about 5 years before burning up in Earth's atmosphere, so it's not forever.
Though that fiery ending has a certain poetic quality to it.
Mitchell certainly thinks so. Plus, the CubeSat will be in a sun-synchronous orbit at about 550 kilometers altitude, meaning it'll fly over the entire globe. With modern spacecraft tracking services, families should be able to locate it and know when it's passing overhead.
That's actually really touching. And importantly, they're not spreading the ashes in space, right?
Correct. Mitchell called that an almost nightmare scenario because the particles could create a debris cloud that could endanger other spacecraft. Since customers only send about a gram, they can do what they wish with the rest.
Thoughtful approach to a sensitive service. Now, let's talk about something that might literally redefine astronomy. Anna, tell us about this massive potential exomoon.
This one's mind-bending, Avery. Astronomers using the gravity instrument on the Very Large Telescope in Chile have detected what might be an exomoon orbiting the gas giant HD 20689-3b, located 133 light-years from Earth. But here's the kicker. This moon is so massive that it might force us to rethink the word moon even means.
How massive are we talking?
Get this. They estimate it could be as much as 40% the mass of Jupiter, or about 9 times the mass of Neptune. To put that in perspective, it's thousands of times heavier than any moon in our solar system. Ganymede, Jupiter's largest moon and the biggest in our solar system, is thousands of times less massive than Neptune.
Wow. So how did they even detect something like this?
Through a technique called astrometry, which precisely tracks the position of celestial bodies over time. The team, led by Quentin Krall from the University of Cambridge, observed a measurable wobble in HD 20689-3b's motion, a back-and-forth movement with a period of about 9 months.
And that wobble is the moon's gravitational tug.
Exactly. Krall explained that the wobble has a size comparable to the Earth-Moon distance, which is the exact signature you'd expect from an unseen companion. The potential moon's orbit is also tilted by roughly 60 degrees, suggesting a turbulent history of gravitational interactions.
So at what point does something stop being a moon and become a binary companion?
That's the million-dollar question. Krall noted that at these masses, the distinction between a massive moon and a low-mass companion becomes blurred. There's currently no official definition of an exomoon, so astronomers generally refer to any object orbiting a planet as a moon.
This could force a redefinition?
Potentially. Krall suggested that as observational techniques improve, our definitions and understanding of what constitutes a moon will almost certainly evolve. He also pointed out that we're likely only seeing the tip of the iceberg. Just as the first exoplanets discovered were massive ones close to their stars because they were easiest to detect, the first exomoons we identify will be the most massive and extreme examples.
Finding exomoons is challenging, I imagine.
Extremely. The signals they produce are minute, often lost in the noise of their parent planet's data. The transit method that's revolutionized exoplanet discovery is less effective for moons because they produce light dips too faint to distinguish. But astrometry offers a new path forward, especially for detecting companions in far orbits, where large, stable moons are more likely to exist.
This research was published in Astronomy and Astrophysics.
It's been accepted for publication there, and it's currently available as a pre-peer-reviewed paper on Archive. If confirmed, this would not only expand our catalog of celestial bodies, but force astronomers to rethink one of the oldest definitions in planetary science.
Incredible. And finally, Anna, we have a story that might rewrite history, or at least rename a famous comet.
That's right. New research suggests that Halley's comet might be wrongly named. Turns out, an 11th century English monk named Eilmer of Malmesbury understood the comet's periodic nature centuries before the British astronomer Edmund Halley.
Wait, so Halley wasn't the first to figure this out?
According to research by Professor Simon Porteous-Wart and colleagues, published in the book Dorestad and Everything After, Eilmer witnessed Halley's comet twice, in 989 CE and again in 1066 CE, and realized it was the same comet returning.
How do we know this?
The events are described by the 12th century chronicler William of Malmesbury, but this connection had gone unnoticed by scholars until now. The 1066 appearance is actually depicted on the famous Bayeux Tapestry, which illustrates the events of that year, including the Norman conquest of England.
So Eilmer must have been quite elderly to see it twice?
Exactly. Given that the comet appears roughly 76 years, He would have been advanced in age when he witnessed it for the second time. And here's a fascinating detail. As was customary at the time, when he saw it in 1066, the king was warned of impending disaster. The comet appeared during the brief reign of King Harold Godwinson, who died at the Battle of Hastings that October.
Medieval people really did see comets as omens, didn't they?
They did indeed. The research shows that comet appearances around this time were consistently associated with the deaths of kings, war, or famine in the British Isles. The researchers even found what might be historical fake news, a comet supposedly seen before the death of Archbishop Cydric of Canterbury in 995, which wasn't actually recorded in the chronicles, possibly an exaggeration to frighten people.
So what are the researchers calling for?
They're arguing that Halley's comet should be given a different name since it had been observed twice and its periodicity understood centuries before Halley's work. Portuguese Wart mentioned that while the research was fun to do, it was challenging working in such an interdisciplinary project alongside a historian. Nevertheless, they plan to carry out further research into periodic comets.
It's amazing how interdisciplinary research can uncover these historical oversights.
It really is, and it shows that scientific discovery isn't always about new observations. Sometimes it's about looking at old records with fresh eyes.
Well, that's all the time we have for today's episode. What a journey we've been on. From rocket fairings to ancient lunar impacts, affordable space memorials to massive exomoons, and historical comet discoveries.
It never ceases to amaze me how much is happening in space and astronomy every single day. From cutting-edge engineering to billion-year-old mysteries, there's always something new to learn.
Thanks so much for tuning in to Astronomy Daily. Be sure to visit our website at astronomydaily.io for detailed show notes, transcripts, and links to all the stories we discussed today.
And don't forget to follow us on social media. We're at Astro Daily Pod on X, Facebook, Instagram, TikTok, YouTube, and Tumblr.
Until next time, keep looking up and keep exploring the wonders of our universe.
Clear skies, everyone.
Astronomy.